Here's another example of a polynomial. We're going to find the zeros and we're going to factor over several different sets of numbers. So the first thing that we want to do is to graph this and find any rational zeros that we can from the calculator. So from this first graph, it appears that this leftmost zero is irrational. Here I have a -1/2 zero. This zero appears to be irrational as well, and this gives me a 0 at 4. So I'm going to do my synthetic division with my rational zeros, and then we'll find the irrational zeros from there. So I'm going to start with my -1/2. Doesn't matter which of these zeros I use to start with, just pick one. Again, if you prefer to use polynomial long division, that's fine. So I'm going to go ahead and do the synthetic division. Remember that when you end your synthetic division, when you're using a value that you believe to be a 0, you should get a remainder of 0. So I'm just going to kind of cross that off. Now I'm going to use this answer and I'm going to divide by the second 0 that I had. So again, when I finish my synthetic division, this is a 0. And that confirms for me that this number that I divided by was an actual 0 of my polynomial. So now what I'm left with at this point is 2x squared plus 0x minus 4. So I want to extract some roots out of that. So this is going to give me 2x squared minus 4 equals 0. You can solve this however you want. I'm just going to do some simple algebra here. So we're going to get x squared equals 2, so x equals plus or minus the square root of 2. So that corresponds, if you check the square root of 2 is about 4.414, and negative square root of 2 would be this 0 that we had over here. So those are your two irrational zeros. So now I have the information to sort of answer the questions that they gave me. So they asked me to find all the zeros in the x-intercept. So for part A, my zeros are x equal -1/2, 4, radical 2, negative radical 2. All of those are also x-intercepts because they're real numbers. So my zeros and my x-intercepts are the same values. All right, so then moving on, part B asks us to factor completely over the set of real numbers. So all of these zeros are real numbers, so we should be able to work pretty easily from that. So if we go from B, remember what we started with was 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8. So my leading coefficient's 2, I'm going to keep that there, and then I'm going to have an x plus 1/2, an x minus 4, and x minus radical 2, and x plus radical 2. So radical 2, negative radical 2, 4, and negative 1/2 are all real numbers. So that is my answer in real numbers. C asks us to factor completely over the set of rational numbers. So now we need to change a few things because not all of our values there are rational values. Part C asks us to factor over the set of rational numbers. So I can't use the radical 2 or the negative radical 2 here. So I'm going to write this f of x equals 2, and then I can keep this x plus 1/2. All of those are rational numbers. We've got x minus 4, rational number. So again, we can't use these two linear terms because they have irrational values in them. So we're going to multiply those out into the irreducible quadratic. So x times x is x squared. My outer and inner terms are going to cancel out, and then I'm going to have minus 2. So that gives me factorization over rational numbers. Every term in there is a rational value. And then finally, part D asks us to factor over the set of integer numbers. So everything in the part C answer is an integer value except the 1/2. So if I just distribute this 2 into this first parenthesis, then that will take care of that. So I get 2x plus 1, and then the x minus 4, and x squared minus 2.